Hope everybody's doing well. We'll get started here. What we're going to talk about is oil management. And, I'm only being a little bit facetious when I say it's not your grandfather's oil anymore. So here's what we're going to talk about. A little bit about the good old days, right? They were good old days. Remember that. We're going to talk about why we did what we used to do. And then we're going to talk about the new world. If you've been in the sessions this morning, you know that things have changed. It's definitely not what it was 30 years ago. It is not what it was 10 years ago. And honestly, it's not what it was 5 years ago. So I won't go into my background there. We did that. All right. So if you've seen me give a presentation, you know what I really want you to do, what I really hope to gain from this presentation is to get you thinking, and to get you thinking in a different way about managing oil. If you've been around the lubrication and rotating machinery for much time, you have worked with a lot of guys who have been there forever. A lot of guys at 30, 40, 50 years working with rotating machinery. So, tell me if you've heard this one. All lube oil is only good for fill in the blank number of years. Depending on which group or which company or which guy you're talking to, that could be 5 years or 10 years or 3 years in some cases. But somebody tells you oil's only good for a certain amount of time. Or you may have heard this one. The most important thing about lube oil is the viscosity. And I'm here to tell you, maybe not. Or this one, oil just naturally wears out. You put it in, it starts to wear out. Or this one, you may still hear this one. Hey, any oil will do. If it's supposed to be ISO 46, any old 46 weight oil, or in some cases 30 weight oil, is good enough. If you've heard any of those things, I'm here to tell you those days are over. So we've always done it that way, but why? Old school theory is that, you put lube oil into a rotating machine and we're immediately stressing it with pressures and temperatures, and it just can't hack it. And at some point, it's just going to start to break down. And so we're going to have to replace it. This theory is still, really prevalent today even. But you got to ask yourself, why do we think that? We have the technology. We can monitor the oil condition. Viscosity is important. If you don't have the right viscosity, you don't have the right cooling, you don't have the right lubrication. But nobody buys equipment these days where the OEM hasn't already figured this out. They know their equipment. They know that modern oils are stable. And provided you use the correct oil that the machine manufacturer approves or recommends, that oil is going to be stable for the life of that machine. The viscosity is just not going to change just by virtue of being in the machine. So, it's extremely important. We have to use the right oil. And more importantly is, don't screw it up. You put good oil in, we don't want to contaminate it. So, in the new world, oil is good. Oil is not going to go bad. Oil is going to do what you need it to do for the life of that machine, provided you do a few things. So instead of planned maintenance, we can monitor and manage the oil. And at the end of this slide, you'll know what I'm really going to focus on here. So here's a paradigm shift for you. People worry about how much oil costs. I'm here to tell you the oil costs nothing compared to the lost production to deal with the oil. If I've got to replace oil in a compressor, the cost to shut that plant down, to work on that machine, to then restart, that lost production is many times more than the cost of a few thousand gallons of oil. And if you start with that paradigm, it's a little different. You know, we talked a lot today in various sessions about oil analysis and what we're looking for and what it's telling you. But the thing is, you know, and I use an oil lab religiously. I love the lab that I use. We work together very well. But, you know, they're in the business of selling me information, and perhaps the package that they offer me is not what I really need. You need to know the risks of your equipment and look for those risks. If you have a filtered, pressurized oil system with a sump and a pump and filters and coolers and all of that good stuff, you don't need to look for the same thing that you do on a self-contained motor bearing sump. You know, here's a clue. I really worry about particulates when I have a filtered oil system. I already know that my self-contained bearing sump has particulates in it. I'm not going to sample for particulates. It's already there. Or if I do sample for it, the limits are going to be totally different. Likewise for a reduction gear in a cooling tower or a self-contained oil sump reduction gear. You know, if it's got a breather on it or something like that, and there's any way for the atmosphere to get in, it's going to be contaminated with dirt. I already know that. The good news is, so does the guy that designed the gearbox. They know that there's going to be airborne particulates going in and out of that machine. So, hey, they told you what oil to use. They designed the right equipment. They designed it correctly. They already know there's going to be particulates in there. So, you know, why track it? So the key is you got to minimize the contamination. If you've got a closed oil system, keep it closed. You know, that may mean some modifications. In previous sessions, we talked about the design of your equipment, and the design of the oil system really contributes heavily to the reliability of that system. You know, I look at the oil analysis for all of my plants, and when I start to see the particulate levels going up on a closed system, I always look to see, well, what's in it? And the analysis that I get from the lab includes the particulate analysis. So when I start seeing silicon and other dirt materials, I pretty much know the guy's not sampling with a nice, neat sample tap. He's doing something else. And so, you know, many times I'll call the plant and find out, oh yeah, they open up the sump. We take the cover off the sump, we reach in, we get a sample. Okay, well, every time we take the cover off the sump, we contaminate the system. There's always those people that think, you know, I need to replace my filters every quarter. And I always ask, why? It's a closed system. They're not supposed to be getting dirt in there. We have DP indications on the filters. What makes you want to open up a closed system just to say we did? So the object of the game is, hey, if it's closed, keep it closed. Even if it's a vented system, don't open it. It's designed to operate that way. The other thing is, there's leaks. It happens. We're taking samples out. At some point, we need to add oil. Well, that's another opportunity for contamination, so we need to be careful about that. Make sure your new oil is the same as the old oil. That new barrel needs to be sampled. Over time, the oil that you put in 5 years ago might have a slightly different formulation than the oil that just came from the vendor. So occasionally it makes sense to verify that, yeah, it's the same oil. The ruler test results are the same. If you don't test it, you don't know. And I will say this repeatedly, do not trust the salesperson at the oil vendor. Everything is compatible if you ask the sales guys. Oh yeah, we're going to put PAG oil in on top of the Mobile 46, but don't worry, it's compatible. You hear that all the time. If you want to know if something's compatible, test it. Then you'll know for sure. Very important. Do not mix oils. If you run with a mobile DTE product, don't put Shell oil in. If you feel the need to change oils, then you should properly change the oil. But oils are not compatible just because they're the same grade. So having said that, we're carefully avoiding contamination. We need to monitor the oil, and the samples that you do need to be appropriate to the equipment. As I said, you don't do a sample on a pressurized filtered oil system that you would do on a gearbox, for example. And this is where you work with a reputable lab, or you find yourself a good tribologist. If I'm not shy to tell people I've been working with Fluid Tech now for, God, 15 years, something like that, 13 years. If I have a question about what to do with oil, I will give one of those guys a call. I'm a reliability guy. I am not an oil guy. So, you find yourself a good tribologist, you find yourself a reputable lab, and you work with them to make sure you're doing the right thing. So common mistake, one that we had in our company for a while and then have solved it, but typically when we talk about predictive maintenance, and in particular oil analysis, we typically talk about monitoring for the equipment condition. We worry about particulates, we worry about wear products. But many times we don't worry about, well, what's the condition of the oil itself? And that is equally important as to what the analysis is telling you about the equipment, is to tell you about the oil condition. I recommend viscosity, particulates, water, acid, ruler, and MPC as a bare minimum for any pressurized oil system. If you want to do additional analysis, that's cool, that's great, depends on what you're looking for. But at a minimum, those are the things I think you should be doing. Now, why did I say that? This is why. And this is what we're going to focus on for the remainder of the meeting today. If you're controlling the external contaminants, your viscosity is going to be stable. Modern oils are stable. You put the right oil in, it's not going to change. So unless you do something to it, that base oil viscosity is just never going to change. So what we're seeing more and more today, particularly in rotating machinery that is now designed with closer tolerances and high efficiencies, is it's going to be varnish that takes you out. And so that's what we're going to really talk about today. I got one question. We'll get to that here in a few minutes. All right. So how do you prevent varnish? Well, you really can't. but you can look to see if you're going to get it. So what you really want to know is, what do we have in the system? And, you know, we use the ruler test a lot. The ruler test is going to tell you, well, how much of your additive package is left. And, you know, here's a typical ruler result from, this happens to be from test oil. So you've got your standard up here in the green line, and then you've got what you're seeing in the real oil in the red line. And typically they'll give you some comment at the bottom that says, well, here's how much is really left. The other thing you want to do is an MPC test. MPC test will typically tell you what's in the oil. And, you know, again, this is what an MPC test looks like. And there's a picture of what you're going to find in a system, depending on what you've got. You know, I am a fanatic about ruler testing and MPC testing, because, you know, varnish is a funny thing. You know, don't ever get me and Greg Livingstone together in a room, because we'll just talk varnish for hours. But the problem with varnish is you either have it or you don't. And once you have it, it's too late. And it has the potential to go from life is good to your bearings are gone in a very, very short amount of time. One of the early machines that I was working on in my career here in Airgas and Air Liquide was a screw compressor in a CO2 plant, and he was forever having problems with bearing temperatures and, you know, just having a rough time keeping his machines running. And when I got involved, we said, well, we've never actually done oil analysis really. So we did an MPC test, and I mean, it was through the roof. And when we took that machine apart, instead of just sending it to the shop and putting a new one in, I had them go do, you know, give me the pictures and send the analysis and show me what's going on. And what we found out was that guy would put a new machine in, a brand new screw in, and within days, the thing would varnish up. His bearings would overheat. His temperatures would go through the roof. And then all of a sudden, his temperatures would come back down. And for years, they thought, oh, that's cool, the bearing's worn in. Remember, we talked about old school thinking in the beginning of this presentation. Well, no, his bearings weren't wearing in, because babbited bearings don't wear in. What was happening was his bearings would varnish up. He'd wipe all the babbitt off. We'd build up about 20 mils of varnish on what's left of the journal, and he was literally running his machine on a layer of varnish. You know, obviously, once we figured that out, we knew what to do with it. But, you know, MPC testing will tell you if you're at risk or not. So this is what I want to talk about really here is, well, now that we know what we're doing, how do we manage the oil? And I got about 10 more minutes, so we're going to go just a few minutes over before. So this is what the new world looks like. This is what we're doing. And so far, this is done very well. So we take the oil analysis. We look and see what we've got. And then we have 3 different paths here. And I know this slide has FluidTech products on it. That's because I work a lot with FluidTech, and this is what we're doing. Not to disparage anybody, but you know, whether you like FluidTech or not, there are other companies that can make similar products, but this is what we're doing. So first thing we do is look at the MPC results. If we've already got varnish, then we know we're going to have to deal with it, because the potential is that varnish is going to get bad in a hurry and has the potential to take out the machine. Now, whether it takes it out on a bearing issue, whether your slide valve starts sticking, whether your turbo expander controls start sticking, doesn't really matter. The impact is the same. It affects your production. And so we're going to add an additive to control that varnish. The next thing we're going to look at is, well, what's the additive package look like? If I have varnish and the additive package is gone, we're done. You can attempt to do an additive addition. There are companies and there are products that can try to restore the additives. In our particular case with the machines and the oils that we use, we have been really unsuccessful at getting through the testing to be able to do an additive addition. Your oils may be different, but you got to go do the testing to find out if you have that option. What we found out is with the oils in our machines, that's really not an option. So we just skip it from now on. But at some point, your additives are gone. You're going to have to replace the oil. Other than MPC, let's say your MPC tests are good, but your additive package is gone. At that point, you need to start planning. You have to make some business decisions. If your additive package is gone, your risk is very high that varnish will occur, but it's not 100% certain, right? I mean, we have machines with no additives that have ran for many years without any problems. Same machine, different plant, same oil, varnished immediately. So you have to determine whether the risk is worth taking or not. In our case, I can't afford the risk. If the additive package is gone, we're going to increase the frequency of sampling and we're going to replace the oil. Just in the last 5 years, you know, oil technology has come a long way. We're using fill for life oils, and that's kind of where we're going with all this. The idea being, if I don't have to replace the oil, we don't. And I literally have machines that have got 20 years on an oil. So quick summary, modern oils, and I mean within the last 5 years, modern oils can last almost forever, as long as you don't crap them up. Because of that, varnish becomes the main concern, and those deposits can happen quickly. And so, you know, we're worried about MPC and ruler tests. Don't change the oil until it's the right time. You know, manage the oil.